Okay, so here we have inverse variation, which is different from direct variation and is one of the other types of variation that we will have. And basically, inverse variation relies on the sole fact that as one increases, the other decreases. So it's not direct as direct variation was. This is now inverse. So with this, we're going to do the same things we did with direct variation, except the formula is very different. It's y equals k 1 over x, parentheses, and can be xy equals k, as well as y equals k 1 over x squared, depending on what you get. So we're going to follow the same process that we had for direct variation. In a closed container, pressure varies inversely with the volume of gas. Okay, so pressure varies inversely with the volume. So what we're going to do here is translate this into this equation, which would be P equals K 1 over V, parentheses. So if I was given any number, I could probably find K and then plug that in and follow the same process that we had before. Now if I have the intensity of light varies inversely with the square of the distance from the source. Okay, so we see here that intensity varies inversely with the square of the distance. So we're going to translate this, and it's going to be I equals K 1 over D squared. Now we put it squared because it says the square of the distance. This one over here just said the volume of the gas. Since this is the square of the distance, we have to put it squared under here. And then from here, we can actually use an example. The best example to use is Boyle's law. Now, Boyle's law tells us that in a closed container with constant temperature, the pressure of gas varies inversely with its volume. Suppose the steam in the cylinder of an antique locomotive exerts a pressure of 210 pounds psi when the volume of the cylinder is 50 inches cubed. So from this, we can say that we have to translate this into the equation. So Boyle's law tells us that in a closed container with a constant, the constant will be the temperature, pressure of gas. The pressure varies inversely with volume. So pressure varies inversely with 1 over V. In other words, when we substitute, it would be 210 equals K times 1 over 50, because that was the volume from this, 50. And then the pressure was 210 up here, pressure up here, 50 inches cubed. So from here, we would just also, since we can do xy equals k, right now we're trying to find k, so we'll do 210 times 50 equals k. And from here, if we go over here, it would be k equals 10,500. So this is our constant of the variation. And then they ask us to determine the pressure when volume is 150 inches cubed. So in order to find that, we would just, over here, we do 150, since we have inches cubed, would be the volume. So what we're going to do is we're going to take the constant and plug it into the formula. So P equals 10,500 times 1 over V, right? So this would equal 10,500 times 1 over 150, which would equal 70 PSI, because we're trying to find the pressure, and the pressure is in PSI right there. So that's a good example of it. And that's basically all you have to do for inverse variation. It's much different than direct variation. You just have a different formula that you have to follow. And you just translate the same process. You translate, find the constant of variation, K, then you plug it in to find whatever you need to find. So if you have any questions, just ask.